Okay, in this video we go over how to go over some different types of numerical statistics, what a statistic is, and how to calculate some of the more important ones in Microsoft Excel. And remember, statistics is all about turning data into information. And at the very basic, a statistic is like a math function where we have one or more numbers and we do some mathematical operations and collapse that to a single number. If you think about a sum is a statistic. If I wanted to know what the total was, that could be a statistic. How do you calculate a sum? Is that you take a bunch of numbers and then the math operator is just you add them up, and that would be a statistic. Another statistic is an average. That's a very popular, very common measure of central tendency. And how do you calculate an average? Is you take the sum, which is again adding up a lot of numbers, dividing by how many you have, and that determines an average. And so we're taking a bunch of numbers and we collapse it to a single number. So think of that as the starting point of statistics. Now, we've already went over this before, but remember there's different ways to think of when you see numbers. Are they statistics or are they parameters? Population parameters, that is just a number that's calculated based on every member of the population. When we look at this chart, almost always we don't know something about the population. We don't know what the population mean is or the population standard deviation. And we want to infer something from a sample. So what we do is that we take some data, a sample from this, hopefully random, and then calculate some statistics on this smaller data set as opposed to this, because this data set is too large. So when we're calculating statistics based on all of the data, which you almost never have, those are called population parameters. If you're calculating data from a smaller subset, a sample, we call those statistics. And that's almost always the world that we're living in. Almost never do we have all the data. If you think about a manufacturing process and we're producing parts and we want to weigh them and see how much they weigh, the population parameter would be every part that we've ever produced now and into the future would be the population parameter. But we'll never have that. So what we do is that we randomly grab samples off of that production line and measure that. So we're calculating sample averages. We may do that many times a day, but still they're sampling statistics. So and you've seen this, I'm sure, in some other, probably in elementary school, middle school, high school. You can think of statistics that measure central tendency, and we can have statistics that measure variability. We also have percentiles, which give us some ranking. And then if we want to model the relationships between two variables, we can calculate correlations. So this video, I just want to focus on the mechanics of calculating these in Excel, and then we'll have another video that talks about how we would use those or what the difference between central tendency and variability is. But first, let's just go through the mechanics of how you do this in Excel. So I've got a spreadsheet out there, and it'll be the third worksheet called Formula. We have our credit card transactions we've gone through. We've got NFL 1976. This one is called Formula. And what I have, it's a little bit busy, but what I have is that I've got different types of statistics. The mean, median, and mode. Maximum, minimum, range, variance, and standard deviation. Again, don't worry too much about what these mean necessarily. We'll get into that. And then a percentile and a correlation coefficient. And then on some of these, there is a difference between the population formula and the sample formula. For example, when you calculate a variance, a population variance, it is going to be a slightly different formula than a sample variance. If you notice, the formula is different. So, but in most of these, they are the same. For example, the average is the same as the average, regardless if you're calculating a population or a sample, you use the same formula. Now, this is the symbol when rather than writing population mean, if I give a Greek S or a Greek M, mu, that's the population mean. If I'm talking about a sample, we use X and with the bar over it, and usually that's kind of hard to write. You have to use some type of objects or equation editor. But so instead of writing X bar, a lot of times you see people just type in X bar. Okay, so let's work our way through, and what I'm going to do is replace these and actually calculate formulas from these numbers over here. Now, we're going to talk about Excel formula, and how you write a formula in Excel is your first keystroke is always equals. That's how you're telling Excel that you're writing a formula, that you want it to return a value based on some inputs. Now, there's tons of formulas in Excel. There's many of these. There's all kinds, and you can look at, we're not going to go through all of these. Most of what I'm showing you would come out of a statistics area, a statistical area, but I've just highlighted some here. So let's just start. If I wanted to calculate the average, or it's also called the mean, and that's the average. This is the formula. It starts with equals average, and if you notice when I start writing, it's guessing and says, hey, I think I know what this formula is, and it's giving you some hints. But that's the formula, and then every formula in Excel has parentheses where you enclose the arguments or parameters of that formula. So I want to take the average of what? Now I could type in some numbers, but I'm actually going to go over and select. So I'm going to put my cursor right in this cell, left click and drag, and I'm going to take the average of this set of numbers. And you notice what Excel did is it replaced what that dragging, or it put in the cell references H2 colon, which means through H15. And so now when I hit enter, it's not going to give you average H2 through H15. It's actually going to give you the average of that, which is 11.7. The number of decimals doesn't mean too much to me on this one. I probably only need to show maybe one, something like that. We can worry about that later. There's also one called the median. The median is if you had the data ordered, it would be the one right in the middle. If you have an even number, it's the average of the two in the middle. So that's the middle value. The mode is what occurs most often. In the case 20 showed up more often than anything else. These are measures of central tendency, mean, median, and mode. The symbol we use for the mean is the Greek M or mu. It's exact same formulas. There's no mystery to this. For the sample average, it's the exact same thing. The only difference between these and these is that I'm assuming that this data set is everything that it's the population values. So, excuse me, almost always, we never know what these are, so I'm actually going to delete them. Almost always, the best that we can do is take a sample and calculate the sample data. Okay, that's measures of central tendency, mean, median, and mode. In measures of variability, or how much spread is in the data, we'll talk more about what that means later, but to calculate it, the two that we use the most often are a range and standard deviation. To calculate the range is that there is no, and by the way, we're going to just look, for now, we're just going to look strictly at the sample data. So I'm going to go over to this side. To calculate a range, the range is, there's no such thing in Excel as a range function. But the definition of range is take the biggest value minus the smallest one. So that's easy enough to do. We can take the max, the biggest value, the maximum. We can calculate the min. And then the range is just the max minus the min. Let me do that again. Again, anytime I write a formula, I start with an equals. I've already got some data out there, so I'm going to reference that cell, hit the minus, this, and so it's taking the value in cell E9 and then subtracting the value in E10. That is the range. The hardest ones probably to understand, and we'll spend more time on this in a little bit, is the standard deviation and the variance. They are related. The standard deviation is just the square root of the variance. If I know the variance, I can take the square root. If I know the standard deviation, I can square it. So let's do it. And there is a slightly difference in the formula depending on if you're working with a population or a sample. We never do this, almost never. We're always looking at sampling data, not population parameters. So I'm actually going to delete those. When we're writing the symbols, we use the Greek letters when we talk about populations, and we don't use the Greek. So this is a Greek S or sigma squared. So when we're doing samples, we don't, they're not Greek, so it's just S and S squared. So let's calculate a standard deviation. And there's different ways to do it depending on your version of Excel, but I'm going to use the one I have now, the SDDEV dot S. That's the formula, SDDEV. That's the standard deviation dot sample. I'm going to grab this data. So you can see that answer is 5.42. We'll worry about that, what that means in a minute. If I take that number, multiply it times itself, which would be that squared, that would be my variance. So my variance is 29.3. I can also just use the variance formula. Either way it works. This is the same number as this one. They are related. The standard deviation is 5.42. If I square that, I get the standard deviation squared, which is 29.3, which, by the way, is the exact definition of the variance. The variance is this. So the variance, if you just use the variance formula, calculates that. Other formulas that we use are percentiles and correlations. Let's not worry about this one. Let's work over here on the sample. A percentile tells you the ranking. It tells you the percentage of values that are at or less your number. So let's say you wanted to come up with the 75th percentile. 75th. So I would start out, type in percentile of this data, and then the last argument, it has two arguments. It has the data, and the second argument is K. K is the 75th, and you've got to put in a real number, so you're putting in 0.75. It's not, you don't put in the percentile, you put in the real number, the equivalent. So if I put in 0.75, it's going to give me the value such that 75% of all the values are at that or below it. So if you happen to have a 16, then that means that 75% of the numbers in that data set are at that or lower. Well, what if we wanted a 90th percentile? We would put in 0.9, and if you scored or have an 18.8, that means 90% of all the values in that are at that or below that. Now, if I make it the 50th percentile, that means it's right in the middle. It is the exact middle. So that means that the middle data point is this, which, by the way, is also the definition of a 50th percentile, is also the exact same thing as a median. The median is the 50th percentile. Same thing. So that number is that one, and it's not by accident because that's the definition. If you rank the data, find exactly the middle, that's the median, and it's also the 50th percentile. The last one I want to go over is correlation. It is a measure of the strength of a relationship. A correlation is the measure of the strength of a relationship. It's for bivariate, it's a bivariate statistic. And all that means, it gives you a number relating to data sets. A correlation coefficient is always a number between -1 and 1, inclusive. So it's somewhere between -1 and 1 on a number scale. Let's calculate it right now. And look what it requires. It's referencing two data sets, so I'm going to correlate this data set with this data set. And actually what it's doing, it's looking at the relationship between 20 and 4, 6 and 5, 20 and 7, and is there a relationship between, you know, when this is big, is this big? Or when this is small, is this small? It's looking at the relationship of that. And if it's close to -1 or 1, it's a fairly strong relationship. If it's in the middle, close to 0, that means there's no relationship or very weak. And we're getting a number, even though it's negative, it's really close to 0. So one way to look at this is that there is very little relationship between these two sets of numbers. So if this was looking at a marketing something and the economic performance of that, I could say there's no relationship between those. Knowing these does not give me any information about these. Okay, in the next video, I'm going to talk more about the differences between mean, central tendency, and variability. Thanks.